Hi there, in this video we're going to look at some equations involving fractions, namely when it's a fraction equals a fraction. There is a lovely method called cross multiplication here, and it's a really important skill to be able to use, particularly when we come to do trigonometry at a later date. So let's have a look. So let's look at this one here. What I've got is I've got a fraction a over b equals c over d, so all in terms of letters. This is just to explain the method that's going to work. What we can do here is normally in equations with fractions, I would have taught to multiply everything through by a common denominator, and that would have cancelled down the fractions. When it is a fraction equals a fraction, there is an easier way, and it's just called cross multiplying. So you multiply the a and the d together, making AD or DA depending which way you prefer, and you multiply these two together, creating BC or CB. Obviously when we've got numbers and letters, we would always put the number to the front. Now it doesn't actually matter which one you do first, and you'll see from the examples I come to do on the next couple of screens, sometimes I will do the A times the D first, sometimes I'll do the B times the C first, and the reason that is it all just depends kind of on where my unknown value is, what I'm trying to find out. So this method is called cross multiplication, and if you've ever seen the smile and kiss method when adding and subtracting fractions, you've already seen something a bit like this, but this is for solving equations. So, and as I said, just to stress, it only ever works when it is a fraction equal to another fraction. If you suddenly stick a numerator in here, for example, if you put 2 plus your fraction equals a fraction, you can no longer do this method, okay? You can't cross multiply here. You would have to times everything by a common denominator. So, let's have a wee look at some actual examples. So my first example here is basically we have a over 4 equals 7 over 2. Now I know some people look at this will say, well, you just need to deal with the divide by 4 times the other side by 4, but for the sake of the process, we're going to fully cross multiply here. So we're going to do a times 2, which is 2a, equals 4 times 7, which is 28. So we've got 2a equals 28, so a is 28 divided by 2, which is 14. Okay, so that's all we have to do there for that one. Next one. This time our unknown is on the denominator, so we're still going to use the process of cross multiplying. I'm going to do this one first because that's where the unknown is with the m. So 2 times m would give you 2m. 5 times 4 would give us 20. 2 times what is 20? 20 divided by 2 is 10, so m is 10. And these are classed as nice basic ones. Let's look at some trickier ones. Okay, so y minus 1 over 3. So this time the numerator has got 2 terms on it. Now I know there's not a bracket there, but the minute there's 2 terms in a fraction, you can imagine a bracket on there. We're going to cross multiply. So my unknown, we're going to do this one first. 5 times both of those things. So I'm going to write it as 5 bracket. And 2 times 3 will give us 6. Then we will expand the bracket, giving us 5y minus 5 equals 6. Your minus 5 will go over and become a plus 5. This line is optional. So 5y equals 11. 11 doesn't divide nicely by 5, so you leave it as a fraction 11 over 5. Now, I'll be honest, you do not always get a nice answer here, so don't be put off. It's very difficult to get nice answers to work on these, so 11 over 5 is our final answer. So just to recap, if there are 2 terms in the fraction, stick a bracket around it. Please don't go straight to this line here, because what you'll find is somebody will write 5y minus 1. They'll forget to multiply absolutely everything by 5. Let's have another one like that. So example 4, this one's got suddenly a lot more in the numerator and denominator. So I'm going to put brackets around both of these. Okay, so where do we start? Do I do the 3 times the bottom or 5 times the top first of all? I'm going to think a wee bit ahead here logically because I've been doing this for ages. I'm going to do this one first, purely because I know what you're like. I know you all like to have the larger letter term on the left, so I'm going to do that one first. So I'm going to do 5 bracket d minus 3 equals 3 times the other one, so 3 bracket d minus 1. So when we multiply these out, this side here will have the higher letters. So that will give us 5d take away 15 equals 3d take away 3. we're going to take our letters left, numbers right. Again, this line here is optional for some of you. Positive 3D becomes negative 3D. We've already got a negative 3 on the right hand side. And minus 15 will come over and become a plus 15. Tidy that up, leaves us with 2D equals 12. 12 divided by 2 is 6. So D equals 6. Okay. As I said, very rare to get a nice answer. I obviously chose my numbers well there. Okay, so just to recap why I did this one first, the 5 times 1, is I was just thinking ahead on where the higher value letter would be, because I know I'm going to have letters both sides, and just out of preference, I did that one. Okay, my last one. Right, so I know some people will look at this one and just go, whoa, what's going on here? So, brackets around the numerators. Okay, which one do I do first here? I'm going to have a 5 times an n again, so I think I'm going to do this one first, because 5n will be greater than 3. So that would give us 5 bracket n plus 4 equals 3 bracket n plus 10. Expand those out, 5n plus 20 equals 3n plus 30. Letters left, numbers right. 5n minus 3n equals positive 30, take away 20. Remember, it's all just doing change side change operation here. That leaves us 2n equals 10. So n equals 2, don't think so. N equals 5. Okay, so hopefully that's been okay. Generally, the first step is the bit that's new. The rest of it is just equations we should have seen before. So good luck.